Hey guys, my name is Ben, and today I'm going to be teaching you Kirchhoff's current law. Teaching you Kirchhoff's current law. Kirchhoff's current law. Kirchhoff.
Did you mean Kirchhoff?
Kirchhoff's current law. So, who was Kirchhoff? He was a German physicist in the 1800s, made strong strides in spectrum analysis and blackbody radiation, but most significantly announced his laws allowing the calculation of voltages, currents, and resistances in electrical networks. Well, today we're going to talk about Kirchhoff's current law. This concept has strengthened our understanding of electrical networks for many, many centuries, and we're going to keep it nice and simple. The theory states that the total current entering a junction is equal to the total current exiting a junction. Before we continue, a junction is a point in a circuit where three or more circuit paths meet, as seen here and here. Now you might be thinking, well Ben, isn't that just a node? Not quite. A node is where two elements or more meet, but in Kirchhoff's current law examples, we mainly look at three or more circuit paths meeting, so in some cases, these two terms could be interchangeable. This can be demonstrated by this formula, where we can see the sum of current entering is equal to the sum of current exiting. Let's have a look at some examples of streams of current. In example 1, we have two unknowns of I3 and I4. To find I3, we look at Kirchhoff's law in junction A, where I1 plus I2 equals I3, and we get a value of 7 amps. To find I4, we look at junction B and use Kirchhoff's law, where I3 equals I4 plus I5, and here we get a value of 1 amp for this unknown. In example 2, we have two unknowns. Looking at junction A, we use Kirchhoff's law to get IS equals I1 plus I2. Subbing in the values we already know, we get an equation of IS equals 9.4 plus I1, but we still have two unknowns. Looking at junction B, we get an equation of I3 equals I1 plus I2, and we have two known values, therefore I1 equals 4.3 amps. We can use this current in our first equation to get a value for IS, which is 13.7 amps. And to reinforce this statement, we can look at this as one junction, where IS is the current going in and I3 is the current going out, both at 13.7 amps, and reinforcing Kirchhoff's current law. Thank you, and hope you learned a bit about Kirchhoff's law.